transcribe into an RNA strand. Okay. Once it makes an RNA strand, it will then be translated into, so again, 3 of these are called what? A codon. Okay. So again, the DNA stays in the nucleus. Okay. A helicase will come in and break it up. Okay. It will be transcribed. Remember, transcribe starts with a C. Transcribe into an RNA. The RNA then leave the nucleus. It leaves the nucleus through the nuclear pores. As you remember, it's going to go into the ribosomes to make proteins. DNA cannot, so again, DNA cannot leave the nucleus. Okay. But your body needs a lot of protein. Protein is not just for muscle building. Virtually all function and cell carry out and complete. Everything in the body is with the help of proteins. Okay. Some of them are called enzyme. We saw those that helps. Enzyme helps with chemical reaction. Okay. So again, the DNA is in the nucleus. Protein synthesis happens in the cytoplasm with the ribosomes. Okay. But an intermediate messenger gonna leave the nucleolus and go into the ribosomes to make proteins. Okay, so this is called a messenger RNA. Okay, so the body, for example, here it is. They just need this little section. Okay. What breaks it is the helicase. Then a polymerase will make this little strand. Okay, it will transcribe into this little strand. Now this strand leaves the nucleus. Okay, through the nuclear pores. Okay, out into the cytoplasm. So again, remember the RNA, to tell between the RNA and DNA, there's no T in RNA. Okay, the T is replaced by U. So that's the messenger RNA. It is transcribed. This is called transcribing it. Using a RNA polymerase transcribe, and then when it's done, it's called termination. Okay. So now, here's that messenger RNA. Okay. It goes to the ribosome. Okay, large ribosomes. The messenger RNA comes in. So 3 of these is a codon. Okay, the codon will bring in something called the anticodon. This is called transfer DNA, transfer RNA. Transfer RNA carries the amino acid to the messenger RNA. It contains the anticodon, and it forms like this, and it builds another strand. Now this is called translating it. Translation uses the codon of the mRNA to determine the amino acid. Thereby, a specific sequence of amino acid is assembled. So this is called translating it. Okay. Again, here's another picture. In this case, this would be a messenger RNA. It's going to go through this giant ribosomes. Then these will be the transfer RNA. It will bring in the anticodon, and it builds on each other, on and on and on and on. And this process is called translation. Translation occurs at the ribosomes. Transcription occurs inside the nucleus, where a messenger RNA is made. Okay, transcription. Once it's done, you got to translate that into useful protein. This is called translation. Okay. Again, the same thing. Oh, here it is. Messenger RNA is made. Then it leaves through the nucleopore out into the ribosomes. Okay. The anticodon will come in. Bam. And then now you have a protein. Okay. Now we're going to learn about cell growth and cell division. So there are different phases in the cell division. Okay, most of your life you're in an interphase. Interphase is business as usual. Nothing's going on. Okay. Cell grow and maintain function, which includes cell replication. Okay. Interphase is right here. Okay. But we're mainly looking at these four. Okay. So, chromatids. Chromatids are packed together and it becomes chromosomes. Okay. And inside there are lots of DNA. Okay. This one is called a centromere. We're going to learn this as we look through them. Homologous. So you see this shape and that shape. It is similar, but it's not the same. That's why it's called homologous, similar. These are called sister chromatids. So this side and this side, the red side, is the same. This side, well, the same left and the right side. But in this case, the front and the back is different. They're similar. The process of cell dividing and multiplying is called mitosis. There's another term we're going to learn. It's called meiosis, but we're going to learn that later. Okay. When one cell becomes two, the two identical cells are identical to the parent cell. So they are clones. Okay. So it's going to divide into two identical new cells. So there are 4 stages. Okay. So mostly here, we're going to learn this. Prophase, metaphase, anaphase, and telophase. You can memorize the acronym PMAT. Okay, prophase, metaphase, anaphase, and telophase. So we just need to know what's going on in each anaphase. Okay, prophase, first one. Okay, prophase, chromosomes condense. Okay, remember, you see this? They're condensing right now, and it becomes visible inside in the microscopes. Spindle fiber emerges from the centrosomes. Here are the centrosomes. Okay, little fibers, spindle fibers start growing on them. The nuclear envelopes will break. Remember, they usually will stay inside. Okay, the centrosome will now start moving toward the middle of the end of the middle. Okay, so we're not going to worry about this stage. Prophase is when everything start happening. Metaphase. Now meta is like middle, okay, where everything's lined up in the middle. Chromosomes are lined up at the metaphase plate. Each sister chromatid is attached to the spindle fiber, originally from the opposite pole. So the spindle fiber, that like extension, it's gonna attach to the middle of it, and then it's gonna start pulling it apart. Okay, so if you look at the picture of the chromosomes, let's divide a line here. Okay, the spindle fiber will, one side from the centromere will attach to one of these, and from the other side is going to attach to one of these. It's going to pull it apart. So this side, the right side, will be going to the right, the left side will be going to the left. So this is called the anaphase state. Okay, where the